はい、それではそろそろお時間となりますので、最初にアナウンスだけさせていただきます。ですね、本日5時から6時のセッションは、Robotics in Tokyo Industry Trends and Perspectives で、イングリッシュセッションになっておりますので、すべて英語でお届けいたします。でですね、本日この後もですね、ずっと2時の方で、セッションを行ってまいりますので、ぜひお楽しみいただければと思います。それではご登壇者の皆さん、お願いいたします。
Hello. Hello, everyone. There's got to be like 300 people in this room. It's amazing, online people. You should see this. I realized I didn't put my name on the slides, but I'm Mike Sudano, Sudano, and I'm from Woven Planet, and this is my co-host.
I'm Marco, also forgot to put my name on the slides. I'm from Ascent Robotics.
And we are both working at robotics companies here in Tokyo. And one of the things that I personally have wanted to do, and I'll get into this in a second, is that I've wanted to form a robotics meetup here, like I'd done back in the Bay Area. So I contacted Marco over at Ascent, and we're starting to pull together different companies that we can have a regular robotics meeting for networking, for hiring, and all types of different things, knowledge sharing within the bounds of intellectual property. So tonight we're going to talk to you a little bit, general introductions, which is right now. I'm going to talk for about 4 or 5 minutes. Then we're going to do company introductions. Marco's going to introduce a little bit about Ascent, and I'm going to talk about Woven Planet, and then specifically our robotics program, which a lot of people do not know about. Then we're going to have a roundtable discussion moderated by Hervé, my colleague, about robotics industry trends and perspectives, specifically in Japan. And I apologize up front for 2 or 3 white guys talking about robotics in Japan. We just happen to work in the industry here, but we absolutely, need more diversity in the field, but also want to explore what's out there right now. So feel free, we'd love feedback as well. And then finally, we're going to do audience Q&A. I don't know if we're going to be able to take online questions, but at the very least, we'll take questions from people in the room. So please prepare your questions whenever you hear something you want to ask about. So let me just quickly go through my history with robotics meetups. There is a person in Silicon Valley named Andra Kie, and she's incredibly connected, and she's sort of a hub for the whole robotics industry out there. She's also a connector of different robotics hubs. So she is the director of Silicon Valley Robotics, which brings together a lot of robotics companies out there. I started going to these events in 2014, and we started out in a little bar on California Avenue, and it grew to something like 50 to 100 people. Not like Thursday gatherings, but it was still a very healthy mix of people. And we would get companies, job seekers, hobbyists coming out to network. I used to drive to Costco and buy about 10 to 15 Costco pizzas and get a bunch of beers. And the events would be hosted at different companies like Toyota Research Institute, where I was at the time. And it was just a fantastic event where people could network, share knowledge. Maybe some collaborations were born there. Maybe companies even started there with co-founders. I don't know. But now that I'm living in Tokyo, and as you could probably tell, a real total freak for the robotics industry and robotics in general, I want to do kind of the same thing, bringing the people I know in the industry I know together for the same purposes. So that's pretty much the background of the robotics meetups. Now I'm going to pass it off to Marco to give his introduction of Ascent Robotics. You could just say next slide whenever you want to go to the next slide.
Thank you, Mike. Next slide is fine. Yeah, my name is Marko Simic, and I serve as a CTO of the company called Ascent Robotics. Ascent Robotics is a tech company based in Tokyo, and we build AI-powered solutions and products for factory automation. But more than that, we actually see ourselves as a bridge between the digital and the physical world. And why is that? What does that mean? So our technology enables robotic manipulation of materials, right? But more than that, it also is able to transform those physical items into their digital twins, which then opens a lot more opportunities for our customers. And before I show actually our tech and our products, I first want to emphasize our team, because that's what makes our company, and I think that's what makes Ascent one of the most unique companies here in Japan. You can go to the next slide. We have a fairly small team, I would say, 34 employees in total, and most of them are actually engineers. So 26 engineers in total, with very different backgrounds and roles, from robotics engineers to AI engineers, simulation, graphics, testing engineers, and many others, right? And even though we are here in Japan, we are also proud to have people from all over the world, and actually it's 17 different nationalities for only 34 employees, which is I think pretty good diversity, especially here for Japan, and one of our strengths. Yeah, sure. Next slide. It's fine. Here, I'm showing two of our products, or actually it is one product for industrial automation, but just applied to the two different tasks. On the left side, or maybe your right side, the blue robot, let's put it like that, is performing bin picking in the industrial setting. For example, any factory here in Japan that is producing some widgets or parts, they usually have some application where they have to move certain parts from one bin to some conveyor belt or something like that, right? And our solution is able to automate that. And on the other side, the silver robot is performing a similar operation, just a little bit more complex due to objects of different shapes and sizes and geometries. And it is applied in this case to logistics industries. You can't see it on the video, but there's also like a barcode scanning and then packing into the shipping box. But you can just imagine Rakuten and Amazon doing that. And next slide. The second part of our company, as I said, digital twins and bridge between physical and digital worlds, is the technology to digitize those items that we are actually handling. And here on the screen, you can see some of the actual examples of real items that you can see in any combini, basically, fully automatically scanned and digitized in high resolution and with high detailed geometry. And yeah, that's a short intro about Ascent. We are also hiring for several roles, so be sure to check our website, and you can talk with me after the session, and I'll be willing to answer any questions.
Thank you very much. And now I'm just going to give a quick overview of Woven Planet and our robotics program specifically. Hello to any Woven Planet people watching. Mount Fuji. So we are building a city near Mount Fuji, and it is going to be sort of a next generation test bed for mobility, is what we like to say. City as a test course for mobility. So our purpose at Woven Planet is well-being for all. And our vision, the thing that's driving us towards there, is expand mobility, enhance humanity, and engage society. So Akio Toyoda said that he wanted to make a mobility company. He wanted Toyota to become a mobility company. And then as part of that, we have our autonomous vehicles. And then we also have this other division, which I'm in, which is working on Woven City and robotics. And we realize that it's not incredibly well known, so we want to get the information out there. We're working currently on 2 different flavors of robots. So we're doing some logistics robots for goods movement. And then we're doing robots in the home as well, for helping people age in place is one thing, assisting people around the house with tasks, cleaning up, things like this. So one of the robots that we have prototype, all of this that we're working on, is a mobile delivery robot for use in the home. So for example, you can put some items on it and have it bring it to another location in the house. It's actually able to lift itself up on a shelf system. And this lift mechanism here can go from about 3 inches up to 2 meters. It's a special spiral lifting mechanism. It's also got a hook on there. So you see that you see the bin over there, it can push it in and out of special cubbies. So here are some videos of the robot in action. Just give me 1 second. See how we can fast forward a little bit here. And you watch this go up. So again, these are all prototype robots, but these are some of the capabilities that we have, both for mechanical engineers, electrical engineers, a whole bunch of different backgrounds. And then we have a gantry robot, basically spider coming down from the ceiling. Robot can recognize objects, pick them up, manipulate them, put them different places. And it's on a giant XY gantry in our mock home, which is in our office. We built a fully mock house. So here are some pictures, a video of this guy in motion. So it's using the same sort of that same sort of shaft that you saw in the other robot, where it can go from the ceiling all the way down to the floor. And then we have 2 arms, bimanual manipulation to move around objects a lot easier than a robot would be able to do with 1 arm. And then this is also somewhere where we overlap with some of the sense work, and one of the reasons why I want to bring together companies like this, because even though we are in sort of different fields of robotics, there are still places where, for example, digital twin and digitization of objects where we overlap. So we are doing digital twins of the room that we're operating in and of a lot of the goods that we're trying to manipulate. So let me show you one more of that, and doing simulation to real objects. So this is my colleague, Ikeda-san, Takuya Ikeda. So as you can see, if the robot can recognize the objects, it can put a bounding box around it, and it can do simulations to test out different grasps of the object. All right, and finally, please follow us. We are also hiring as well. We'll have some swag outside at the table out there. And we have, in addition to full-time positions, we also have internships. So if someone is not ready for a full-time position, please come work for us in an internship capacity. And please also be on the lookout for more meetups like this. So in addition to this session now, we're going to be networking and chatting all night. Our next meetups, they may be consistently here at Thursday Gathering, or we might end up having them at different offices around Tokyo. So yeah, we'll be discussing that. And now we'd like to talk a little bit about the robotics industry. So I'd like to invite up my colleague Hervé. We're actually a little bit ahead of time. I think I should have had more slides. This never happens. All right, so welcome, Hervé. And we're going to go through a number of different sort of prompt questions. And we're just going to sort of give our perspectives on that. So if you want to start us off.
Yes, so how did we arrive at the current state of robotics in Japan? Because if you look a little bit at the current status, it is fairly well known that Japan is actually a producer for about, I think, 50% of the robots sold in the world. And I'm kind of interested in basically your perspective on how did we get here? And I guess then the next question, which would be in the next slide, is where do we go from the current state? Because I think both Woven and Ascent are fairly new companies. And so I think, yeah, I'd like first to have your opinion on what the general industry is doing currently and how did it do it?
Sure. So one of the places I used to work was Kawasaki Robotics, and they do a lot of industrial automation, arms and robot factories. So especially after researching this, found out that Kawasaki was actually one of the first to introduce sort of an industrial robot arm into Japan with the Unimation, the Unimate robot. And that's sort of how it started in the car industry in Japan, in factories. And then eventually developed from there, but it wasn't a super easy road. So there was some sort of pushback that was had. But in general, comparing and contrasting the uptake in the US versus Japan, one of the most interesting things I read today was that given Japanese sort of job security versus the US, where you would sort of be a salaryman or something like this for life, people weren't so much concerned with being displaced by robots in Japan, which is kind of shocking to me. So yeah, that's one of the original updates.
Well, it is also interesting to know that that first robot Unimate was not built in Japan, so it was not Japanese technology. It was actually built in US, and then its first application was in Japan. So Japan recognized the importance of robotics even before US, right? So they started adapting them right away, and I think they just started to, they realized the potential, and as you all know, efficiency is very important for Japan, and robots definitely offer a lot of efficiency, which led to the development of many good robotics companies here.
Yeah, that's kind of what I'm interested quickly is like, how do you think that, well, basically Fanuc became the biggest robotics company in the world? What do you think makes their robots so, so interesting? Is it just luck, or is there something to it?
Okay, so I don't know the full Fanuc history. I do know that Fanuc robots are excellent machines, and we have them in our offices, and our customers use them. So definitely high quality. And how they won the market, I'm actually not sure. On the other hand, well, that's maybe, yeah, that's it.
Okay.
Um,
Maybe move to the next
yeah,
kind
this
of,
is this is actually
I think this is
relevant.
what we were discussing, right? So it's so far basically Japan has been producing excellent machines, but I think currently we're maybe hitting some limits of using just excellent mechanics. So I don't know if someone wants to talk a bit about this, like the limits of pure, great hardware, maybe what we need going forward. And yeah, what do you put? Yeah, so this is what we had asked about the current trends, like, because I think the idea is there's going to be new use cases for robots that maybe those industrial robots cannot perform. So yeah, if you could maybe give us your idea of what's the next big thing in that sense.
So industrial robots can't hug you, essentially. Like, cobots is a huge thing now. And one of the things with cobots or any robot that works around humans is that the programming, in addition to the hardware being really good, the programming has to be good to sort of recognize those danger states. And also the interaction has to be good. So one of the things that at least Japan has been known for traditionally is really good manufacturing, really good hardware. One of the things that Silicon Valley is known for is really good software, and maybe somehow forgetting the hardware in that. So I think bringing that software over from the US, that software expertise over from the US, is sort of the next step in making sort of the best of both worlds. And I think organizations like here that are sort of promoting that Silicon Valley style of thinking, bringing together founders and venture capital people, is really good and going to be necessary for usability in the future, humanoid robots and other things. To get out from behind the cage and working with people and around people, I think is going to be the next steps.
So my opinion is that the hardware is becoming commoditized, and the last kind of major evolution of, I guess, the revolution in the space was cobots, right? But that was 15 years ago or so, and there's no space. I mean, there's definitely space to innovate, but like the innovation in the hardware space is much slower. So we can see manufacturers from China, from Germany, all catching up with robotics here in Japan, and they all offer very similar hardware platforms that they're like almost indistinguishable. And yeah, I think that the software will be the next battleground, and I think that the Japanese robotics OEMs are still lagging in that domain. I think they did recognize the necessity of good and modern software, but they're still not like proficient, and they're still new to it basically.
Yeah, and this is maybe where we can have a little bit of a different opinion, because we showed from Woven side how there is a built, how can I say, hardware and software is built at the same time. Whereas as far as I remember, the Ascent platform builds on some other manufacturers' hardware. So do you, what are like pros and cons of both approaches in your opinion?
I would just like to say that Harvey is actually a huge expert in robotics. He has a PhD, and as for Ascent, yeah, we have a different approach. You do the integrated solution, hardware and software. We only build software that goes onto the existing robotic platforms. I think that our plus point is that we work with many different hardware platforms and can service different needs of different customers. Maybe, for example, some manufacturer in Osaka wants to use Yaskawa robots, right? For some reason, historical reason, and we can accommodate that, right? But the benefit of your approach is definitely a higher degree of control and integration of hardware and software. So yeah, pick your poison, I guess.
Yeah,
Okay.
yeah, we can move on to the next one.
Yeah, because I think this is maybe the next point. We discussed a bit about the different approaches, but I think there's many industries in Japan that are looking to either automatize because they've never done it, or to increase their automation, or to change their processes, and maybe even beyond industries, various places would like to introduce robots. So what do you think is, maybe we'll start with opportunities, like industries in Japan that actually need automation, and where do you think there's an opportunity for a new robotics company or for our current companies?
So I'd first like to ask, at least for the people in the room, can you raise your hand if you have a robotics background? Okay, 3. Awesome. So this will be good. So what is it? Let's see. Can you raise hands online? I don't know. I don't think so. I'll just pretend that no one has a robotics background online. It'll make this a lot easier. So one of the things that roboticists hear and have heard for the past 20, 30 years is that, especially in Japan, the age pyramid of younger people to older people is sort of inverting. So whereas people in their 80s were a very small percentage of the population, and newborns were a very large portion of the population, that is now sort of moving up into sort of an urn shape, where Japan is an aging society. And with that comes along a lack of, say, younger people to do labor tasks, not to mention taking care of elderly individuals. So automation kind of needs to happen in that sense. Japan traditionally has been a little bit more resistant to have foreign labor, especially for caretakers and things that are very personal in that nature. So automation kind of has to happen in order to support the graying, so to say, population, and also to perform the tasks that might not be there. And there's a lot of fear. There's always been a lot of fear of robots taking people's jobs, but I think more and more we're starting to see that is not necessarily the case. There are a lot of places where there are labor shortages, in fact. So I think, especially here, there's a huge opportunity to fill that gap.
Two main industries that lead in automation globally, not just in Japan, are automotive industry and electronics industry. And actually, last year, I think that the electronics industry took over the first place from automotive industry. And most automation is still in large enterprises, because those companies have more means to invest in future. So vast majority of SMEs, especially here in Japan, is not automated, and they're slow to adapt these solutions for various reasons. And on the other hand, one industry that's coming up now and investing a lot of in automation is logistics. because pandemic accelerated automation in logistics. We realized that humans are squishy and we need our goods delivered in one day. So better use robots for that. But yeah, SMEs are generally reluctant to adopt automation because that's something new for them. They're suspicious. They don't know how to upskill their workers. They don't know if they'll be able to maintain the solutions and stuff like that. But on robotics industry and new companies are innovating also in business models. So we're offering not just upfront solutions, but also robotics as a service and stuff like that.
Okay, yeah, so I mean, that was good for opportunities. So I think we discussed a bit about, well, there's many places. But so what are the challenges? So I think we can discuss this kind of the general Japanese challenges about maybe building a new business here, but there's also maybe some technical challenges on going to SMEs. So maybe let's start with more the organizational challenges. You know, what makes maybe Japan challenging for innovating, if there is anything?
There is. How do I not get fired?
Do you want me to?
I'll take a stab at it. So, you know, tradition is definitely pushing against that. I'm sure a lot of you are familiar with the agile methodology of working rather than waterfall. So you want to iterate on things. Maybe someone at an electric car company might say you want to break things fast, which we don't believe in, but you want to move quickly and quickly realize where you can improve things and do that. Rather than waterfall, where say you're developing a whole system, you do one thing and you have to wait for that whole thing to be done. It's not as efficient. So I think generally Japanese ways of working has relied on that older way of thinking. And that really presses up against where people just want to move fast and develop something. And if you can't get your product out fast, you're not going to have market traction and you're going to lose your opportunity. Also, just in general, organizing things like using GitHub or CI tools or anything for modern code. I was working at unnamed Japanese companies that were still using, for example, folders to keep their CAD data in, and we had to pass the CAD data back and forth with email and folders, and that's terrible for versioning, where if you make a change and your teammate makes a change, it'll get lost. So I think as the systems get more complex and the lines of code increase and the devices and the files get bigger, there has to be more modern approaches to how you do things as well as what you're building. And I think that is one of the challenges, is adapting to that modernity.
Ascent is a bit more customer oriented than your company. So we do see challenges both in the business side and tech side. On the business side, and again, as Mike said, we are just two white dudes in Japan, right? But my impression is that the business deals here in Japan are generally slower than in the Western countries, which for small companies and startups is an issue. We need to move fast. We need to generate revenue. So if we need many meetings and slow decision process, that is not good for us. But we are managing to overcome that. On the tech side, I think that robotics has a lot of room to grow. Still, robots are mostly employed in structured environments. And yes, we are offering some new solutions for unstructured environments. But in general, when a robot has to operate in a fully dynamic, changing, unstructured environment, that is still an issue. And that is something that I'm sure that Woven is working on and Ascent is working on too.
Yeah, maybe we can move on to.
Yeah, I mean, I guess.
Unless you had any other challenges.
I mean, I don't think it's maybe if people are not so familiar with robotics, we can maybe explain a little bit why unstructured environments are challenging, not going into details of neural networks and things, but just because I think it's very natural for us humans to handle unstructured things, and it might seem a bit strange that robots are just incapable of it. So
yeah, as Harvey said, for us humans, movement is natural, and we don't think about it, right? We can just do this and like rotate the phone, throw it in the air and catch it.
I was hoping you were going to drop it.
Yes, I was thinking about it. Don't drop it. Don't drop it. But for robots, that is actually very hard because first of all, they don't have joint mobility that we have. We evolved like through hundreds of thousands and millions of years, right? So we are optimized for operating in the real world. And also robots do not have a perception as we do, right? For us, again, seeing and perceiving is natural and something you don't think about, but for robots, everything that they receive is just ones and zeros, and somehow we have to come up with programs to convert those ones and zeros into images and videos that mean something, and then based on that, we also have to add real-time control for our huge robotic arms, and all that is very challenging. So when things are moving, it's kind of hard to catch everything, to recognize everything. Oh, this is the end of the chair, this is the beginning of the TV. I can go between them, or I can pick this TV at this edge or this edge. All that has to be somehow learned by a robot, and is generally still hard to do that.
Yeah, I can actually go back to one of the questions that we received at our last meetup. So someone asked a question. We were talking about doing digital twin and simulation to real. And they said, well, if the bottle is there, why don't you just have the robot go and pick up the bottle, which is like a tautology. It's like, it's a bottle, you can pick it up. Okay. And people chuckled at the question at the time, but I think it is a really good question for anybody who wants to know why not just have the robot go here and pick it up. So what companies are aiming to do, the holy grail of robots is a universally applicable robot, a robot that can do sort of anything around the house, completely adaptable. You're going to have not only this bottle, you're going to have a bottle where it's, I don't know, summer Aquarius flavor or Aquarius for men or something, where there's going to be a small label change and your robot is not going to be able to adapt. So there are a lot of different variations in the real world. The real world is really messy, and robots traditionally are bad with dealing with messy situations. So you may have heard of deep learning, neural networks. One of the things that we do is train the robot on millions of different pictures of objects from all different sides, so that if it does see a little different label, it can infer from that, oh, actually, this was the type of bottle that I know about. It is shaped like this. Oh, it's a little bit different over here, so maybe I can do a different grasp. We have to sort of bring it up to that level of intelligence. So that doesn't just exist outside of the box, but I can definitely see people assuming that it does, because in our brains, it's natural.
yeah, I mean, that's interesting. And
Do you want to add something, Hervé?
Do
you want to add something to the challenges?
To the challenges in terms of technical challenges?
Yeah.
I think we haven't talked about it so much because we didn't have any pictures, but robot actuation is actually really poor. I mean, if you look at the robot hand, it's often two parallel fingers, and I can only challenge people here to lift anything that's a little bit heavy with just two fingers, or anything that's like this flat on the table. It's actually really difficult. And unfortunately, some people in the research area, in various research areas, have produced much better grippers in that sense, that are very dexterous and are able to, are soft and can kind of grasp things. But then the issue is for us roboticists how to control those hands, how to use them effectively. And because, of course, the advantage of two fingers is very simple. You just need to find one place and close, done. But if you have a finger, a hand with 5 fingers and I don't know how many tendons and things, it's actually really difficult to grasp things effectively. And I believe that this is a big challenge for, how can I say, physical intelligence in a way. have robots be able to interact with complex objects and do actual complicated things. And I believe it's a challenge at Ascent as well. If you have these complicated manufacturing scenarios with simple grippers, it's actually hard to do anything.
Yeah, definitely. In manufacturing, there are like countless shapes and very like weird items, and sometimes customer wants to use like a parallel gripper because they already have that somehow. And then we're like, no, you just can't just grasp that item with a parallel gripper. It's just not physically possible. Like, so we have to overcome stuff like that.
And also just think, like, Hervé was saying, the parallel gripper, that's one degree of freedom. That's how we talk about joints, they're degrees of freedom. You have to program for that degree of freedom. So just imagine in your hand alone how many joints there are and how you have to coordinate that motion to not only do things like grip. A few years back, actually maybe more recently, there was a robot. The big thing was that it was able to manipulate a Rubik's Cube with one hand, just something simple that we might do without thinking. So that's the level of complexity that we're kind of working with. Yeah, we're cool. Humans are cool.
Yeah, and I remember at the research conference somewhere, some person presented a climbing robot, and I was very interested in that. But as it turns out, they couldn't get a hand that can actually grip thing and closed.
Mm-hmm.
So basically, they made a big hook and just say you just slam the hook into the rock, and that works.
That probably also couldn't pick up the packages.
Probably.
That Marco.
And I think that's kind of where we are right now with hardware. It's especially for manipulating things, we tend to have either general solutions that don't scale very well with various items, or very custom things that work very well, but then don't scale at all. So it's a bit.
Yeah, actually, we still have a good amount of time. I'm going to bring up something that we were talking about today. So in terms of having a robot in a house that can do something, you all know the Roomba. The Roomba was a big hit because it did one thing really, really well, and that was vacuum. And you don't see robots that can do everything. So what we were talking about is why don't you just come up with a robot that can do like two things really well, just to make your way sort of there. So sort of a mix between that, super hyper focused and general purpose. And that's something we still haven't really seen yet. Factory robots are doing factory things. Telepresence robots are doing telepresence things. Still no good solution of a robot with a screen and an arm on it, as far as I know.
So houses are built for humans, and robots are just not humans. And that's like we have stairs, we have like small steps, we have like weird, I don't know, wardrobes and stuff. So it's just hard for robots to operate in that environment. But I think that Boston Dynamics Spot is maybe closest that we have to a home robot at this point. That it can navigate the home very well, go up the stairs, down the stairs, and it's great hardware in general. But definitely not a solution yet.
Cool. Last one. We can move on to the
I think
next one.
We're already kind of there, but it's like, what comes next? And I would say the first thing is maybe what's the target? What in your mind would be a hit product or application, something that you could see being a revolution that everyone would try to buy in Japan? And I mean, it can be as dreamy as you like first, and then we can work backwards from there.
So I think for the industry applications in factories and logistics centers, where we can control the environment and have an exact task that we have to do, and especially in our case, like bin picking and piece picking, we just need to improve and scale the current solutions. I don't think we need anything that revolutionary to solve those tasks, and many of them are actually already solved, right? But for general robots, I do think that we need improvements both on the hardware control and perception and cognition side. And yeah, many companies are working on that. Ascent is not doing home robots yet. So one thing that maybe we're overlooking is that when humans evolved and we evolved everything together, right? Perception, control, bodies, cognition. While right now, how we build robots is we build hardware separately, then we bolt some control algorithms separately, maybe with some consideration to that hardware, and then we add perception to it, which is again disjoint from hardware and control. And finally, we add some like logic to control all that. And all four components are kind of separate from each other. And maybe that's the issue that we're having.
Yeah, that's a really good point, and that also goes to sort of evolving in a human environment. So just as you were saying that, I'm thinking if only there was a company working on some sort of, futuristic city where robots would operate, and like a woven city, perhaps. So I think that uh, I think that home automation is going to be huge, whether it is in the form of humanoid robots or ubiquitous automation. And one of the things I learned about recently, I'm currently looking for to buy a house or buy land and build a house. So one of the things I learned is that Japanese houses kind of have a lifetime of 50 years due to earthquakes and things like this. So if we are now at the point of rebuilding houses, why not outfit the houses to have this sort of functionality that could interact better with automated systems? Cabinets that open for you, or floors that move to create more space, walls that do the same, things like this. So I would hope that sort of a little bit more ubiquitous automation is going to be there, probably instead of your robot butler coming to serve you dinner. I also feel like even though there is better associations with robotics in Japan. Many people grew up with robots in manga and anime and things like this, whereas the US had Terminator, and that's what colored the view of robots and really tainted our industry, kind of. But I think even though people have that sort of, better feeling for robots in Japan, I still think that just having that universal robot in the house is still really, really far away. So having something that's a bridge to that automation is going to be the way to go.
I want to add my personal opinion on the robotics and like service industry. I actually wouldn't like to kind of replace all the humans in the service industry. I think that me personally, I like humans. I like interacting with the people, and wouldn't just like to replace those people with robots and just I don't know, to be served coffee by a robot. I don't. That's not appealing to me personally.
But that's a good question because, well, there is one company in Japan right now building robots where humans actually control the robot remotely. So I don't know if I should name them since they're maybe here tonight, but what do you think about this kind of solutions where we actually have the humans interact with the world through a machine, and would that be acceptable for you?
So again, I would still like human in front of me, but I do think that actual solution is good for some other stuff, because we do have a lot of people who can't participate in the workforce due to different reasons, right? Maybe disabilities or something, and enabling them to actually interact and contribute to society is a great thing. So I think their tech is pretty good, and yeah.
Yeah, I'd have to agree, and especially there's the cafe that's close to our office in Nihonbashi, where all the robots are controlled remotely by members who either have disabilities or just aren't able to be there, which is a really fantastic idea. And then you're right, there's other telepresence companies, especially in the age of COVID, that's really becoming increasingly important. Yeah, this might be a good place. You want to start Q&A?
Yeah, I mean,
We're about
if
time.
there are any questions, we'll take them. Otherwise, I have many more points
Okay.
now. I can ask the questions if needs be. So yeah, if there are any questions in the room, I would be happy to take them.
Yeah, I don't think we need robots to project a dystopian future. I think that's already here. So don't blame it on robots and don't watch Westworld. It's really good, but yeah, I'd say do your research and don't believe at face value the sort of any alarmist takes on robotics, especially ones that are sort of outdated now. Terminator. I'd say, you know, research into the current state of the art. We are nowhere near general intelligence or anything like this. So
Unless
look at
Harvey is one.
which one?
Unless Harvey is like in disguise AGI.
Oh, he is. He is a robot. Yeah. So I'd say look into the actual state of the art, what it is now, and learn what's actually going on and hear the challenges of the people who are actually working on these robots. And the more that the general population knows about this, the better, because then they could sort of come to terms with what the reality is of the industry.
So robots are just tools, right? They don't have their own volition, and how they get to be used depends on people who have the power, right? So it's not robots' fault, right?
Yeah, but I think it's still an interesting question. Like, what are there any ethics in robotics in general? And you know, at a sense that woven, what are we doing to make sure that robots are used correctly? And I agree with you that we don't have, you know, you make a robot, at some point you set it, and those people will use it, and you cannot control that. But I do think we are still trying to make things that are, yeah, used correctly.
So in a sense, we build solutions for industrial automation, so we are not harming anyone directly. But yeah, there is definitely like a question of replacing humans in the workforce. But as Mike noted, in Japan, that's actually a big problem, that there is not enough people to work. So robots are not harming the society, they're helping the society. And more in general, there are definitely some robots that are being used for more, for less innocent purposes. But I don't have insight in that.
I have a lot to say on this subject, but I don't know how deep we should get into it. Yeah, I will just say that there's a concept in Japan, I think it's pokayoke, meaning like you can't do it incorrectly. There's a little tab on your charger, so you have to plug it in the right way. So helping people to do the right thing in terms of using the robots is fantastic. Of course, we can't dictate everything that someone does with the robots, but just as an example, at TRI, we built a robot for the Olympics last year, so you can go back and look it up. It was a robot that actually ran and lit the flame. I think it passed it off to Akio Shacho. And this one, of course, we had to think of physical security and digital security. We didn't want it to get hacked. So, of course, we put those rails in place. So we can only do, I think, so much, but I think as an industry, we should be held to an extremely high standard that we are putting dangerous tools out there, you know, sort of like, you know, any autonomous driving companies, named or unnamed, that you should take responsibility that you're putting this out into the world, and it could be misused in certain ways. But yeah, come talk to me after this for more thoughts.
That sounds great. Thank you.
I think that Harvey should answer this. He has a PhD in humanoid robotics, so.
Yeah, so I mean, in my time in humanoid robotics, we were using HRP2, so Humanoid Robot Project #2, which is actually an old robot. So my view is maybe a bit tainted by this robot, but to answer the question very quickly, it was very, very difficult at the time to just get the robot to move. And when you add on top of this the perception, which nowadays, we do a lot of neural networks, those things really take power. So actually batteries became a problem. And yes, the power of the robot itself was a big issue. We couldn't lift heavy things because, of course, so first there's the power in the arm itself, but then even beyond that, if you try to grab something heavy with the arm completely outstretched, actually the robot doesn't have the mobility and the power to balance. And so this was a difficult point. And I think it's unrealistic in the very near future to have useful humanoid robots. However, I do think the technology is coming along and that the research community is very active actually in trying to get better robots, better compute, better algorithms, and that we will get more general solutions. And I do believe that there is a use, especially in home robots, because as Marco said, in the home, everything is designed for humans. And so having a human-shaped robot would actually be a huge advantage because you could go up the stairs, you could go down, you could open the cabinets that are above, kind of high. These kind of things are currently impossible with a spot robot because the arm is just too short and it cannot reach that high. But yeah, I think the challenges are still huge. And if you've seen even, the Atlas robot by Boston Dynamics, for example, is a very impressive robot and they have great control algorithms. But if you look at, for example, how they do the detection, usually they put a little big QR code on what they want to pick, because I think it's really hard to have the perception and the control working at a level in which you can perform really useful tasks. And it will take time, I think, to get to that level.
So several years ago, DARPA had like a grand challenge in robotics. And if you check those robots, they're kind of all humanoid, but almost all of them failed. And even the ones that didn't fail, they were like super clunky and slow. And when it comes to Tesla bots, Elon operates on the Elon timeline. So whatever he says, just add a couple of years. So it's fine.
Yeah, and actually just to add to that DARPA challenge, actually the winners of the challenge had a robot that could walk, which was important in some parts. But the robot also had wheels in the knees. So actually they were driving around for the most part because just walking is actually difficult. And especially, I talked a little bit about physical intelligence, but us humans are so good at using the arms and taking balance by pushing on something or pulling on something. And that simple task is actually still difficult.
Yeah, so I don't want to discount. So your question, you're wondering about fitting all those components in that structure, essentially. I don't remember if there was a scale on that render, so that could be a 20-foot tall robot that there's. I wouldn't put it past them. So I don't want to discount that they could fit all the components in there, but like they were saying, there are a lot of other challenges, and I don't know. I would think that we would see solutions to those challenges popping up at conferences or things like this if they are indeed solving them. But I would love if that robot came out and did what they say it would do. That would be fantastic. But who knows? Yeah. Yeah, I don't know what specs they're targeting, so they could use existing stuff and just maybe it's not that great, but I don't know what, for example, what repeatability they want on the arm or how fast they want it to go. So they could use current components and put it in a nice, looking body. Yeah, TBD.
Yeah, and I'll just add that it's not, how can I say, the components themselves, you can buy them off the shelf. but also the way you integrate them is very important. So if you look at, for example, the Boston Dynamics people for Atlas, they actually kind of 3D print the hydraulics inside the chassis, which is a huge weight saving. But a lot of the components are actually built. But doing this kind of offsets the things. And the shaft people, if you remember from that same challenge, they won the, not semifinals, but the first version. And their big innovation was not the motors themselves, is that they had a very innovative cooling system, which allowed them to drive the motors at about, I forget, 1,000% peak torque or something without burning them. And this was really important. And so I believe that, yes, if you just buy motors off the shelf and plug them into your existing aluminum chassis, no, it's not going to work. But I think there's a lot of innovation to be done around the components themselves that can be enough, maybe, depending, again, on the specs they want.
Do we have time for one more question, or do we have to wrap up now? One more. Okay, we'll take one more. Yes.
Yeah, you talked about the safety talked about that social problem or legal, regulatory, any new technology, stuff.
Yeah. So currently, I could talk about some of the work that we had done at TRI. So we were talking about their sort of home care robots. And one of the things that we specifically wanted to stay away from at the time was either actually physically interacting with a human or giving them even medication, things like this, where we would leave this up to sort of medical divisions of the company or things like this. So certain things like that we have to watch out for if we're directly interacting with humans or doing anything that might, cause them harm.
So a lot of industrial systems and robots included are also defining some standards too, like ISO standards. So for example, if you want to have a collaborative robot, you have to pass the certification and show that actually your robot meets all the requirements. So stuff like that exists. It's still primarily on the software, on the hardware side. Actually, autonomous vehicles it's a big challenge for autonomous vehicles to get the verification for their systems, because auto regulation is very strict, and there are many rules that you have to follow. So all the AV companies that are working on their stack have to certify their perception systems, their sensors, and stuff like that. In the industrial automation, especially in like speaking and stuff like that, there is not much certification on the software side, just like for the hardware stuff.
Yeah, and I'll just add that currently, so as we said, the autonomous vehicles very strict, the industrial machines also very strict, but service robots are typically not very regulated just yet. So if you look, for example, at the Pepper robots, you might have seen them in the SoftBank places. Of course, the engineers thought about it, but I don't think there's a specific standard for it. But actually behind the scenes in a number of ISO committees, I'm sure that a lot of people are looking at it. And things, I think, are moving because more and more products are popping up. And so I'm sure that people are looking into it.
So if you want to create a crazy robot, now is the time.
Get in before the standard. No. I think we're gonna call it here. Thank you everyone for coming to the session, both online and in person. Please be on the lookout for more. Our tentative group name is Robotics in Tokyo, because there's already a company called Tokyo Robotics. So talk about getting
not affiliated.
Not affiliated, no.
But they're welcome to join us.
Yes, so if you're a robotics company or someone who is interested in robotics, please be on the lookout for more of these meetups, either here or at other companies. And maybe eventually we'll have a website or something like that if there's interest. And that's it. Thank you. Enjoy the event tonight. See y'all.
はい、ありがとうございました。これにて5時から6時のセッションを終了いたしまして、あと1、2分でですね、次のセッションが始まってまいりますので、現地の皆さんですね、ネットワーキングされたい方は、会場の外でぜひ登壇者の方とネットワーキングしていただければと思います。で、次のセッション、6時から7時のセッションは、J スタートアップアワー第124回、日本初グローバルスタートアップの作り方をテーマにお話ししていきます。 オンラインの皆さん、準備ができ次第、次のセッションを始めてまいりますので、今しばらくお待ちください。現地の皆さんですね、ぜひバーの方で飲み物を飲みながらですね、ネットワーキング楽しんでいただければと思います。